Hello everyone, I am Akhilesh Kumar Srivastava from ABS Engineering College. In the series of operating system lectures, we will discuss today about the priority and preemptive priority scheduling. It is known that whenever the processes are running in the system, some of the processes have got the priority. It means the systems executing the processes should be executing the processes on the basis of their priority. The higher priority processes should execute the CPU first, and the lower priority process should execute the CPU late. But there will be inherent demerit of this algorithm. If the high priority processes will keep coming, this will lead to the starvation of the lower priority processes. So, the outline of today's lecture will be, we will first discuss the CPU scheduling basics, and then we will go for the priority scheduling, then to the preemptive priority scheduling, and finally the merits and the demerits of the priority and preemptive priority scheduling algorithm. We have discussed about these things earlier also, but just to ensure that you have the enough knowledge about these figures, let us have a look at these terms once again. In the system, when the process is arriving or when it is submitting to the it is submitted to the ready queue, that time is known as the arrival time. So, arrival time is the relative time with the system whenever the process arrives in the ready queue for the execution. This time is known as the arrival time. Burst time of a process is the amount of time the process requires for execution at the CPU. We usually represent this burst time in terms of CPU cycles. However, it can be taken as the physical time as well. The turnaround time is the time or the amount of time a process spends in the system. At some point of time, the process must have entered the ready queue, and after the completion, if it finishes at Y time, then the difference between finishing time and the arrival time will be known as the turnaround time. The waiting time is the amount of time a process is actually wasted, or you can say that the amount of time which was required for the CPU execution and the total amount that the process has spent. There is a huge gap between them. So, the difference between the total time the system has spent or the process has spent in the system minus the burst time is known as the waiting time. This waiting time may be sheer wastage of time or sheer time for waiting in the queue, or it may be the time for spending in the I/O systems as well. So, both are taken into the account while computing the turnaround times. Finally, the response time is the time at which the process gets the CPU for the first time. It may so happen that a process is allocated to the process for a very short duration and it is taken back, maybe because of any reason. So, the response time is the first time when the process is allocated to the CPU, and it may finish in with the first allocation of the CPU when the system in which we are dealing is the non-preemptive one, and if we are dealing with the preemptive versions, then a process may get the CPU for short amount of time and then it can be preempted back and it will be scheduled later. We have already discussed about the round robin scheduling, which actually is a preemptive version wherein the response time is very high. When the process is submitted to the system, it is allocated to the CPU in a quick succession, and then after expiry of the time quantum, the CPU is taken back. Once the one cycle of all the processes gets completed for the CPU execution, the process once again gets the CPU. So, the cycle repeats. So, these are the parameters that you should know before going to the priority and the preemptive priority scheduling. So, here are the basics for the priority scheduling, that each process is given a priority each of the process executing in the system must get a priority, and all these things means the priority should be stored in the process control block. According to the information available in the process control block, the dispatcher finds out which process should be allocated the CPU. Priority is actually a number. It is a numerical number that ranges from 1 to any higher number. In some of the system, the lower number denotes the higher priority, and the higher number denote the lower priority, or vice versa in some other system. So, let us deal with the priority scheduling. We are first going with the non-preemptive version of the priority scheduling, wherein when a process is allocated to the CPU, it runs till the completion. So, we have initially in this snapshot of a system only P1 process available at 0 time. So, here we have a Gantt chart, we are maintaining a Gantt chart. The time in the Gantt chart, let us say, starts at 0. At 0 time only the P1 process is available. So, irrespective of its priority, we will allocate this to the system. It has a burst time of 4. So, it finishes at 4 time, even though it is of the lower priority, since it is the only process available at 0, it will execute till the completion. Now, at 4 time, all the 4 processes, all other 4 processes means P2, P3, P4 and P5 are available. Since all are available, we will have to look at the priority. Out of these priorities, the 5 number priority is supposed to be the highest one, but P4 and P5 both the processes are having the same priority 5. We have a conflict. Now, since we have a conflict, we will resolve this conflict with the help of the process ID. The process having less ID must have arrived first, or must have been allocated this number first, and P5 must have been allocated the process ID later. So, that is why we select the process number P4 for allocation at the CPU. So, let us allocate this P4 process first at the CPU. It has a burst time of 5. So, let us allocate this up to 9, and at 9 time the P4 process finishes. At 9 time we will have a priority of process number P5. So, let us allocate this, and it should also run till the completion. It has a burst time of 2. So, it runs up to 11. Post its execution, there are 2 processes which are remaining. They are P2 and P3. Out of P2 and P3, 4 number is larger, means the 4 priority number is larger. So, P3 process will be getting the priority over the P2 process for execution. So, let us allocate this P3 process at the CPU. It will run till the completion. It has a burst time of 1. So, at 12 time it finishes. After this we remain with only one process, that is P2. So, let us allocate the CPU to P2 process, and it has a burst time of 3. So, it runs up to 15, and after this all the processes have finished. Let us compute the parameters. First, the completion time, I told you earlier as well. For finding out the completion time, let us go from the right to left in the Gantt chart. Last time you see a process in the Gantt chart is the finishing time. For example, P2 process is being seen last time at 15 time. So, the finishing time or the completion time for P2 process will be 15. Similarly, P3 process is seen at 12 time. So, let us mark its completion time as 12. P5 process is finished at 11. So, let us mark its completion time at 11, and P4 process is finishing at 9 time. So, let us mark the completion time of P4 process as 9. The same for P1 process is 4. So, we have computed the completion time. Completion time is the baseline for computing all other parameters. So, let us find out the turnaround time, the time a process has spent in the system. So, very simple formula for finding out the turnaround time is subtract the arrival time from the completion time. So, for P1 process this figure will be 4, for P2 process this figure will be 15 minus 1 14, For P3 process this figure will be 12 minus 2 10, for P4 process this will be 6, for P5 process this will be 7 because 11 minus 4, because of 11 minus 4. Now we should find out the wasting time or the waiting time. So that will be turnaround time minus the burst time. So this figure will be 0, this figure will be 11, 14 minus 3, 10 minus 1, this figure will be 9, this figure will be 6 minus 5 means 1, 7 minus 2 means 5 will be the waiting time for process number 5. Let us find out the response time. I told you earlier as well, the response time is the time at which the process is allocated the CPU for the first time. So since these are the techniques which are non-preemptive one, so the response time will be equals to the waiting time. Okay, after waiting this much time a process will be getting the CPU. Otherwise you can move from left to right in the Gantt chart, that will tell you what is the first time the CPU is allocated. You find out wherever in the Gantt chart a process appears first. So the P1 process appears at 0 time, P4 process appears at 4 time, P5 process appears at 9 time, sorry, P5 process appears at 9 time, P3 appears at 11 time and P2 appears at 12 time. Since these are the relative timings, we should subtract the arrival times from the found value of the response time. So 0 minus 0, 12 minus 1, 11 minus 2, 4 minus 3, 9 minus 4. So these values come out to 0, 11, 9, 1 and 5. You can see that these are exactly same as the waiting times. Now about the preemptive priority scheduling, whenever we are dealing with the preemptive priority scheduling, in that case when a new process comes and that process is of the high priority, then we can preempt the lower priority processes. Okay? For example, in this snapshot of the system, at 0 time only one process is available, that is the P1 process. P1 executes for 1 unit of time, after which we can see that the process number P2 has also arrived. Since we are considering that the higher number represents the higher priority and the lower number represents the lower priority, P2 process is having higher priority than P1 process. So let us allocate the CPU to P2 process. Now P2 runs for 1 unit of time only, after which the process number P3 has also arrived. We have 3 processes in the system, out of which P3 process having priority 4 is the highest one. So let us allocate the CPU to P3 process. We are preempting the running process so that the higher priority process can get accommodated in the CPU. So now P3 is having the highest priority among the 3, we will allocate the CPU to this P3 process. The P3 process runs for 1 unit and it completes, after which P4 process at 3 time P4 process has also arrived. We now have a conflict between 3 processes P1, P2 and P4, but the highest priority process is P4 process. So let us run this P4 process for 1 unit of time, let us say up to 4, and then another process P5 arrives. The P5 process is having a priority of 5, but earlier a 5 priority process was already running. So let us deal it in the first come first serve manner. Let us resolve the conflict with the first come first serve manner and let the P4 process run till the completion. So P4 process is continuing and it will run up to the completion time 8. Now we have P5 process, which is the highest priority process. We have 3 processes among which the conflict is there, P1, P2 and P5. Here P5 is having the highest priority, so P5 will be allocated the CPU, and since no more process is coming from outside, it means that here is the time that we can allow the processes to run till the completion. If more processes were coming, in that case we must have preempted a process for checking the priority of the other processes. So here P5 runs till the completion. P5 has a burst time of 2, so it runs up to 10, and thereafter we can select either of P1 and P3 P1 and P2, but P2 is having high priority. So, let us select P2 for the execution. It has a remaining burst time of 2, so it completes at 12, and later on we can select the P1 process which is having burst time of 3. So, we can finish this process at 15. So, this way we have found the completions of the processes, or we have found the order in which the processes are allocated to the CPU. Let us compute the parameters one by one, find out the completion time. For finding out the completion time, you will have to traverse the Gantt chart from right to left. So, you find that P1 completes at 15 time, P2 completes at 12 time, P5 completes at 10 time, P4 completes at 8, and P2 completes at 2 time. Sorry, P3 completes at 3 time. So, this is the completion time. Similarly, we can compute the turnaround times, the amount of time a process is spending in the system, that can be found by completion time minus the arrival time. So, 15 is the figure of turnaround time for P1, 11 for P2, 1 for P3, 3 minus 2, 8 minus 3, 5 is the same for P4, and for P5 it is 10 minus 4, that is 6. Let us find out the waiting time. Waiting time is found by turnaround time minus the burst time. This is the wastage of the time that a process has actually done in the system. So, 15 minus 4, 11 is the waiting time for first process. For second process it is 11 minus 3, 8, 1 minus 1, 0 is the waiting time for P3 process. It was given the CPU the moment it has arrived. So, it has waited for 0 amount of time. So, 5 minus 5, 0 is the waiting time for P4 process. It means P4 process was also given the CPU the moment it has arrived. Then 6 minus 5, 6 minus 2, 4 is the waiting time for P5 process. Let us compute the response time. We can find out the response time by moving from left to right in the Gantt chart. So, the first time process P1 is shown is seen in the Gantt chart is at 0 time, P2 is seen at 1 time, P3 is seen at 2 time, P4 has been seen at 3 time, and P5 was seen at 8 time. Since these times are relative, let us subtract the arrival times from the response times that we have found in the table. So, 0 minus 0, 1 minus 1, 2 minus 2, 3 minus 3, and 8 minus 4. So, that you can see that the response time is very high for the processes in this case, but the process which is having the least priority and the high priority processes will keep coming, and that process will be starving, that will not be getting the CPU for a very long time. So, there is a starvation for the low priority processes. Similarly, we can solve another numerical. This is the snapshot of the system which is to be solved using the priority scheduling. It means this is the non-preemptive priority scheduling. A high priority process is there with the 12 number, and a low priority process is there with the 2 number. At 0 time only P1 process is available. So, let us allocate the process to the CPU at 0 time. It is a non-preemptive version. So, it will complete or it will run till the completion. So, at 4 unit of time we can see that process number P2, P3, P4 and P5 are also available. Out of these 4 processes, you can see that the highest priority process is P4. So, you should allocate the CPU to P4 process. Non-preemptive version, this P4 process will run till the completion. So, it will finish at 9. Up to 9 time, process number P6 and P7 are also available. So, out of the processes P2, P3, P5, P6 and P7, P6 process is having the highest priority 12. So, let us allocate the CPU to this process. It runs till the completion, and then we can select the another process which is of the higher precedence or next higher precedence. So, this way we can solve this. Now, let us solve this problem with the preemptive priority scheduling version. So, in the preemptive priority scheduling version, as we have already solved a problem, we will preempt a process when a higher priority process is coming. So, let us solve this problem. Here we have a 0 number at 0 time only process number 1 is available. So, process number P1 runs till 1 time, and at 1 time P2 process is also arrived. So, in this question what you can see that 1 is representing the high priority and 7 is representing the low priority. We have not seen the priority at 0 time because only one process was available, but later on we will have to see the priority of the processes. So, at 1 time P2 process has come, which is higher priority process than the P1 process. So, we will have to preempt P1 and P2 is given a chance to run. P2 has a burst time of 3, since no process can have a higher priority than 1. So, P2 process runs till the completion. When it completes at 4 time or up to 4 time, process number P3, P4 and P5 are also available. So, we have 6, 4, 6 and 7. These are the priority. Out of this, 4 is the lowest number, it means the higher priority. P3 process will be given the CPU. Okay, P3 process will be given the CPU. Now, when P3 runs for 1 unit of time only, means from 4 to 5, at 5 time P6 process comes. P6 process is having the priority 3, and this priority 3 is larger than the currently running process P3. So, we will allocate the CPU to P6 process. Okay. Let us subtract the amount of time that a process have already run. So, this has run till the completion, it has run for 1 unit of time. P3 has also run for 1 unit of time, and then the P6 is running. So, P6 has run for 1 unit of more time, and then P7 has come. P7 is having the priority 4. So, 4 is larger than 3, it means 4 is having less priority than P6. So, let P6 continue till the completion. So, when P6 runs till the completion, it runs up to 12 time, and at 12 time this process will finish. So, we have the conflicts resolved, we do not need to preempt the process anymore. The processes, all the processes till now have come. So, we should just see the precedence or the priority and allocate the process till the completion. So, P6 has run till the completion, it has a 0 burst time. Now, P2 has a burst time of 0 now. So, conflict is in between P1, P3, P4, P5 and P7. Out of this, there are 2 processes having the priority 4, one is P7 and the other one is P3. To resolve this conflict of the same precedence, we should deal with this in the first come first served manner. It means the process which has arrived first should be allocated to the CPU first, and the process which has arrived next should be allocated to the CPU next. So, we should allocate the CPU to first the P3 process. So, P3 process runs till the completion. P3 has run for 1 unit of time, 3 unit of time is already remaining for this process. So, let us run this process till the completion. After this, we can select the P7 process, which is having a priority 4, the highest one among the remaining processes, and it can run till the completion. It has a burst time of 7. So, P7 process can run up to 22. After this, we are remaining with the processes P4, P5 and P1. The process P1 and P4 are having the same priority 6. So, they should be dealt in the first come first served manner. P1 has come first and P4 has come later. So, P1 process should be allocated the CPU and it should run till the completion. It has to run for 4 unit of time, and then the process number P4 will be taken up and P4 will run also till the completion. It has a burst time of 6. So, 32 is the time at which this P4 process will finish. Finally, we have a process P5. Let us allocate the CPU to this P5 process, and P5 process will run till the completion. It has a burst time of 2, so it finishes at 34. So, I believe we have taken all the processes and have run till the completion P1, P2, P3, P4, we have completed P4, we have completed P5, we have completed P6 and we have completed P7. So, let us compute the parameters, let us find out the completion time with the help of this Gantt chart. Let us look at the position where the processes appear for the last time in the Gantt chart. So, let us move the Gantt chart from right to left. P5 process finishes at 34, P4 process finishes at 32, P1 process finishes at 26, P7 process finishes at 22, P3 process finishes at 15, and then P2 finishes at 4, and whereas P6 finishes at 12. So, these are the parameters for the completion time. Let us look at the turnaround time. We know that the turnaround time is equals to the completion time minus the arrival time. So, 26 minus 0, 26, 4 minus 1, 3 for P2 process, 15 minus 2, 13 for P3 process, 32 minus 3, 29 for P4 process, 34 minus 4, 30 for P5 process, 12 minus 5, 7 for P6 process, and 22 minus 7, that is 15 for, 22 minus 6, 16 for P7 process. Let us find out the waiting time, the amount of time the processes have wasted in the system. That will be turnaround time minus the burst time. So, 26 minus 5, 21, 3 minus 3, 0. So, process number P2 has not waited any time, it was given the CPU the moment it has arrived. 13 minus 4, 9, this is for P3, 29 minus 6, 23, 30 minus 2, 28, this figure is for P5 process, and so turnaround time for this process will be 8. So, this is also 0, and 16 minus 7, that is 9. Similarly, you can find out the response time by moving from left to right in the Gantt chart. So, you see the P1 process at 0 time, you see the P2 process at 1 time, you see the P3 process at 4 time, you see the P6 process at 5 time, you see the P7 process at 15 time, then you see P4 process at 26 time and P5 process at 32 time. If you subtract the arrival times from these values, you will get the final values. So, 0 minus 0, 1 minus 1, 4 minus 2, 26 minus 3, this minus 4, this minus 5 and this minus 6. So, 0, 0, 2, 23, 28, 0 and 9. So, this is how we find out the values for the preemptive and non-preemptive priority scheduling algorithms. So, the merits of this priority scheduling is that we have a lower response time for the high priority processes. The processes which are of high priority, they will be executed first, they will get the CPU in a flash, but there will be starvation for the lower priority processes. We already have discussed this, that the lower priority processes will keep starving if our system is allowing the high priority processes to take the charge of the CPU. So, this is the reference operating system concepts by Silvershad and Galvin. Thank you.